speaker here.
Cartons of eggs have gone through the roof, but you can still get a bargain haul at a Hamfest. Here's what I took home from the Moorabbin and District Amateur Radio Club's annual Hamfest. This is intriguing. We've got a meter movement, a switch, and rare and expensive vernier reduction drive. Yes, it's missing the knob and the dial. Doesn't matter. It does still offer the mechanical reduction. That's really handy for a lot of radio projects. And inside, also prized, this dual gang variable capacitor. The box could be handy too for a small transmitter or receiver project. Solid state basics. Not to be confused with solid state design for the radio amateur. Though both are published by the American Radio Relay League, and both were associated with Doug D. Moore, the late Doug D. Moore, and this came out in 1978. Anyway, the previous owner has got their name and address there, and you might notice a L30121 number. That was basically a call sign, although for shortwave listeners, an ID number given to shortwave listeners who were members of the Wireless Institute of Australia. So they could use the QSL Bureau as a listener when they were wanting cards from amateurs. So, solid state basics for the radio amateur. I'd say it would be a beginner's manual. Solid state design for the radio amateur came out, I think, the previous year or maybe 2 years before. So this one's a good starter. So it starts off with the basics, a theory, and then you get on to the circuits, transistor behaviour, a lot of maths and graphs, and here we get into the practical aspects. So you can start off with a 2 transistor audio amplifier, then a complete audio amplifier, push-pull class B, uses audio transformers. These days you probably would have something that was direct coupled, and then it gets you into test equipment there, little RF voltmeter, and a small receiver. There's various receiver stages. These are RF amplifier stages. Bit on audio. So yeah, this has a lot of circuits and pictures as well, how you might build it. So they're developing here a local oscillator for an 80 meter receiver. So if you're to build things in all these chapters, you're going to end up with a receiver. And have a look at the breadboard they've got here. They've got just pieces of printed circuit board with the squares. I'm not sure if they etched them just by putting insulation tape on the parts you wanted to keep, or whether they used a hacksaw or knife. Anyway, you've got it laid out on a big board, and you've got it as a battery powered receiver, a direct conversion receiver for 80 meters. So it talks about various mixes you can use and modules. So it's very, very modular. That's how they teach you. There's some layout information on the board. And here we're moving into IF amplifiers, and you've got filter there. So I have a feeling that you're going to be going into superhet receivers. There we are. It even says so there. A superheterodyne receiver for 80 meters. So this is a step-by-step guide, and there's the completed receiver. Oscillator design using transistors. So a 10 watt 80 meter transmitter. So yeah, the basis of this is going to be a transceiver, or at least a transmitter receiver pair. Now, very interesting is that they are holding a power transistor stud mount variety. I'll talk about that a little bit later on, because there's another item. Anyway, if we keep going through, they talk about the design of matching networks, impedance matching between the stages, and power amplifier there, where it connects to the antenna, probably a few watts output. VFO design, so they must have started with crystal control before. Anyway, this will give you some frequency agility. Then here it goes into ICs, so there's a few things you can do there, and now we're up to audio amplifier, so I think a bit more gain in their receiver. And it's quite comprehensive, going into TTLs and logic. Here they've got a digital readout, so you could have had that on your receiver. And there is all about frequency counters and the modules you need for it. So this is a pretty basic introduction to using solid state. I suppose around this time, 1976, there would be quite a lot of amateurs who, although they might be experienced, they might be old timers, they might have only built things with vacuum tube gear, they might have bought something like a Yaesu FT101, but they might not know much about the practical side of building with solid state, so I think this book is designed for them. There's a mention here of a 2 watt transmitter, only a few transistors, crystal controlled, and it uses, they say it uses VHF transistors, which is handy in that they have a lot of gain, but the problem is that if they've got a lot of gain, they can also be difficult to tame, so they talk about that. And so yeah, that's this book, Solid State Basics, all for the princely sum of $1. Now on the same table, down at the bottom, there were boxes in the bottom. Anyway, this didn't cost me anything. This is basically a VHF RF amplifier. Just with one transistor there, you might be able to read it, 2N5590. So just looking at the size of the coils, I'd imagine it would probably be VHF. But I would suggest with this stage, I would take out all the parts, but I would use this U-shaped thing still. You can mount various components on it. In fact, just looking at that, there's some holes there, so that would have been for other transistors. For higher power stages. The important thing is that the bottom of the transistor is screwed directly to your heatsink. So definitely with this style of transistor, you need a really good thermal and physical connection to your metal heatsink. It needs a fair amount of thermal mass. If it doesn't, then you'll find that touching the top of the transistor will be very, very hot, and you may destroy the transistor. So don't use these sorts of transistors without a good heatsink connected. You've got potential to take out some of the small coils, put in some larger coils. You might have this as a Class C amplifier. That would be okay for CW. Otherwise, you might need to put some DC bias for amplification on SSB. So that's one other item. This looks like a really good loading coil for a vertical type antenna. So an antenna you might use by the beach, maybe you'd tie it to a pier or have it on a squid pole in the sand. Ideally you'd be having this around the centre of the antenna, but it will work for base loading. It is round on a PVC there, and not only that, but someone has gone to all the trouble, presumably with a lathe, of putting the spiral there. Don't know if you can see it, but anyway, it's indented, so the turns are firm there. Now, you're not going to have as good a cue with this compared to if the coil was air round, but it should still be okay, sort of. Now, what you might want to do with this, maybe if you've got an old soldering iron, maybe you can just punch some holes just with a hot soldering iron. Just don't inhale because the smell is going to be noxious from the plastic. But anyway, if you did that near every turn, maybe you'd do it in a sort of a spiral, then you can more easily attach alligator clips to this. So then you can tap up and down the coil for the amount of loading. Not too heavy, definitely a promising part of an antenna project. Now, at the end of the Hamfest, the club table had things for free and bits and pieces. Anyway, there is this interesting looking pencil case. Sockets, very, very useful sockets. SO239s. I'll probably unscrew them from the wall plate. And also very, very useful, especially given the cost of them. You know, you've got adapters, the number of different coaxial connections you've got now, like you've got N connection, got SO239, so that's a converter there. This one here is also very handy. It goes from a SMA, or there's an SMA male there, to a SO239, so that's handy if you're connecting bigger antennas to handheld transmitters or receivers. So yep, that was a very, very good find. Right here, PL259 to PL259, always handy. Just realised something with this, you might just be able to fit into this pencil case, and if you do that, there's a little bit of extra room so you can have your wire, and that is your small portable vertical antenna that you could just put on a squid pole. So that's really, really handy and just protects the coil. Just having a look inside here, these things fill out. Just a small coil and, well, some form of tuned circuits. Finally, we have the mystery box. The seller didn't know what it was, but for only $5, it was too good to resist. A signal strength meter, a tuning control, a microphone socket, what I think is a headphone socket. So it looks very much like some form of transceiver. Could be AM, could be SSB, could be double sideband. Anyway, it is quite heavy, so it might even be more than QRP. Inside, well, it's a bit of a mixture. Homebrew, mostly on matrix board, but here you have on a printed circuit board, audio amplifier using the famous LM380 and audio preamp. So this is going to be for the speaker connection. Here on its own board, 741 op amp, and what I think is the microphone amplifier. There are 3 relays here, probably to do with the transmit-receive switching. And here we have a big board, a lot of things on it. You've got some op amps there, and here you've got 4 diodes, broadband ferrite. So this is going to be a diode product detector. Here you've got a 4-legged device, probably a dual gate MOSFET. Either an RF preamp, or it could be a first mixer. It may well be a superhet receiver rather than a direct conversion. In here, this is a bit of a mystery, but the box looks like it houses the VFO. You might be able to see through there, maybe not. There's a vernier reduction drive. So overall, it's been built very, very well, though it was by someone who didn't bother with printed circuit boards, as you can see here. Next thing we'll do is have a look at the other side. But overall, VFO, transmit, receive, microphone amplifier, receive audio amplifier. This is probably receive audio filters, product detector, maybe an RF amplifier or a mixer. So this is almost certainly a received part of the circuit. The other side, most notable, is the very nice printed circuit board for the transmitter output stage. You can see there's a MRF 475. Now, I'm a bit puzzled at this. There is a heat sink there, but the biggest part of the heat sink is on the rear panel. I would have mounted the transistor straight onto the biggest part of the heatsink because the heat's going all the way through here. But anyway, it might be good enough. And we have here, this looks like the Pi Network filter. We've got driver stage here, probably the 2-in push-pull. Anyway, there's a pair of 2-in 3053s. And then another transistor here, that might be the pre-driver, not quite sure. But anyway, this is probably going to be something around 5 or 10 watts output. Right near the antenna socket is this transmit receive relay. That's what I think it is. Another relay here, and interestingly, this control you've got another toroid. Maybe it's a pre-selector on receive, not quite sure. And it only goes half a turn, so I'm thinking this is a small variable capacitor, so I'd say this is probably an RF pre-selector, and it has a tight front end. Here is a separate board, audio transformer. You might be able to see there CA3028 and a little trimmer capacitor. This looks very much like a balance modulator, and when we follow the lead it goes straight into here. So what I think this is, there's no crystal filter, no evidence of phasing circuitry, no modulation transistors. This is almost certainly a double sideband transceiver. As for its frequency, we haven't applied power yet, haven't measured anything, but looking at the value of these capacitors in this Pi Network, 0.0018, so 1.8 nanofarad, that is quite a high value. I would say this is a double sideband transmitter or transceiver for 160 meters. We don't know yet, but anyway, Here's the VFO compartment, nice box. Let's get a screwdriver, open this up and see if we can have a look inside. Now, an interesting thing, when I just turned the variable capacitor, is you've got this wire there. Maybe they wanted to provide a reliable path to earth because you've got it connected to the spindle, and as you turn it, the wire moves around. I've not actually seen this in any circuit or recommended, but it is quite strange because enough use will put stress on the wire and eventually it will break. Normally there would be a tab here on the spindle connecting to one side of the variable capacitor. Just there is where the stator plates connect, and that is right near the coil. And there's a trimmer capacitor there that will be used for calibration. Just looking at this, there are 3 transistors, so there'll be 1 or 2 for the VFO and another buffer. You might not be able to see it on the camera, but there is faint marking, possibly in pencil, on the frequency display. That's 70, 80, 90, not marked, but that's near the end. So we've only got 1.8 to 1.875 for 160 motors here in Australia. So I think these are in 10 kilohertz steps or 10 kilohertz increments. So 1.88, 1.87, 1.86, 1.85, that's clearly 50 there, 1.84, 1.83, pretty sure that's 30, that's probably 1825 there, 1820, 1815, 1810, and I can see 2 00s there. So yeah, so I think that's 1.8 megahertz. So I'm 90% sure this is a transceiver for 160 meters double sideband, and a direct conversion as well. Microphone socket probably on off. This might be a pre-selector, probably for the receiver. Not sure if this is CW and SSB, though I didn't see a key socket. There's probably volume, RF gain and fine tuning, and there's the speaker socket. This is my collection from the Hamfest. Pretty good bargains for $11 total, and let me know any Hamfest finds you've had. Enjoy these videos? Want to start in amateur radio? Well, check out my books, Ham Radio Get Started for USA readers, and the Australian Ham Radio Handbook for those in Australia. For more information, visit my website VK3YE.com or search their titles on Amazon.